Welcome back, generals, to another Let's Fix Generals Zero Hour to make the best game ever. Good. Last session we did some progress. Yeah. Yeah, for the parsing the variables, variable symbols. Yeah. Static variables. Yeah. Static. By the way, we should probably also say variables. Variable. Static. I wonder if this is true. I mean, I wonder. Yeah, this global thing needs a bit more thought, I think. But before going this direction, before continuing with that, I wanted to understand what the description is. Description of the symbol. All right. We don't have a lead on that yet. It could be some index of the symbol or maybe something else. But it would be great if this was symbol descriptions. Return information about the symbol. Symbol descriptions. What is that? Is that like a thing? No. Symbol descriptions. description. So yesterday, we're looking a bit here. We found this page. This one actually gives nice infos. Symbol descriptor none. Does it say anything about description? The address of the variable represented by the ngSym is not contained. The debugger gets this information from the external symbol. External symbol. Name, descriptor. What does a descriptor mean? The symbol descriptor following the colon in the string fields following the G is a type reference or type definition. In this example, is a type reference to the basis C type char, the first source line in char? How? G2 char? The symbol descriptor following the colon is G. Type reference or type definition. Type reference to the basic C type char. But we don't have this. We only have colon G. We don't have the 2 here. That's for GSym. What about STSym? Same here. S1 int. We don't have that. That's too bad. Initialized static variables are represented by the NSTSym step. The symbol descriptor part of the string field shows a variable. Shows if the variable is file scope static or procedure scope static. Well, that's not true for our case. The source line 3 static int equals 2. Static int sg repeat equals 2. Yeah, so the address refers to some section and a word, so it's a 4 bytes. Yeah, no, word is 2 byte actually. Double word is 4 bytes. A line 4. Huh. Can we get hands on this alignment here? That would be useful information. Well, if it refers to this and not just to this. Okay. Descriptor type ref. Name descriptor type ref. And what is this here? They don't say what this number means. Ah. Okay, they refer to the number for this symbol thingy. Okay. No. Yes. No. Yes. 40? Is that true? Uh, 28. Yeah, okay, then that's correct, yeah. Okay, so... Yeah. Okay, so we do have this times 1. So this is how you know it's an array. We can probably figure a bit more about this number if we create a std map and or set, and then we put the uint16t some variable description. No, and then here we just, let's move this down here. Static, and then we do dot emplace symbol dot description, and then we take a look what kind of values we get in there. So that means we put a breakpoint. We put a breakpoint here. Yeah. Let's see what it says. All right. And so 943. Okay, 6, 7, 8, 9. They look like IDs to me. 943. But we have 2,663. Maybe. There's some holes here. 500 missing. 499. Yeah. $9,000. Huh. Another theory would have been that it's a byte size of the data. But then I would have expected here some ones and fours and twos. There's none of the fours would be the most likely for 4-byte integer. But it starts at 6. What does description mean? Let's put a breakpoint here. It's very strange. So this one has description 45. G. 45. There's no address, right? Yeah. Let's get one with an address. Here. Okay, so here we have description 436. Well, it's a bit large. How about we look for some that has a smaller one? 20, that looks good. Okay, so S-ANSI dick map, yeah? So there is a value. Let's go for hexadecimal. Let's go for copy value here. And then we search for it here. Dick map. So this looks like it's 100 hex bytes, right? I don't understand how this alignment comes to be. Like, how does he know that the alignment is 4 here? It's probably some trick, but I'm not seeing it. How would you know that this thing ends here? Look at this. So there is a variable here. And it could be that there's already some manual work done here in this database that has determined how big this thing is. It looks like that this one knows that it's 1 byte. I don't know if someone punched it in. I didn't, but I received the database, so someone else could have changed that. Yeah, right now I have no clues on how we know how big is the data. Data, pure data segment, align 32 bits. But then it can somehow change the alignment. Could it be that whenever you have... My suspicion how this works is that you have an area that so no symbol is referencing this address. So it's like an address that is unused, and then it's padded with X amount of bytes, and this is how you know what the alignment is. That's my guess how this works, right? So here, for example, we have a byte, and then we have 3 empty bytes, and now we know the alignment is 4. One, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so you need 3 more bytes to align. Now, It looks like it knows the alignment for all these types here. Right, if you look at this, it seems to have full knowledge. Yeah. So I suspect that this already knows by default. Well, this one here looks a bit odd. Yeah. Okay, to me it looks like it's not automatic. It probably needs to be manually mapped, right? That's how it looks, because here the texture data, to me, this looks like it should also be 4 bytes. And here, should probably be also 4 bytes. Yeah. Here as well. If we look at this thing here, if it's already here, no, it's not. Where's this comment coming from here? Can we search for this guy in here? No. No search. It's probably user comments. Yeah. I don't know how to find this though. It's probably somewhere in here. Maybe we can search here. Geometry names. Huh. Maybe we have to search here. Geometry names, no. Maybe we have to search somewhere else. Names. Geometry names. There it is. Well, that didn't help. I would have hoped that there's more to it, but maybe that's not. Geometry names. I mean, if it makes this comment here, why is it not making the same comment here? That's strange. Yeah, it's a good question. How do we it would be, so what we need for a variable is to understand what type it is and what the data is that it refers to. But I don't know if that's possible. Maybe it's not. Basically, we would need to know. Yeah, we would need to know the type. But maybe we don't have it. It would be great to get this data for the static variables, but I don't know how to do that. Pixel shader. This is a 1 byte. We search for this. One vector. It's a great name. One vector. Yeah, I don't know. Speaker types. Here from this bit flags we could deduce the length from this template argument. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. No, 13 is here. This one. And this is an end. Base string. How can we go back? Yeah. I suspect these are user comments here somewhere. Inserted to G%. Slightly a float. 3F is typically a float number. Yeah. Yeah. Declaration table. Let's ask I think we already asked this ChatGPT, but I forgot the answer and it probably was wrong. Like this yesterday, we asked what these things are and it gave it, yeah. It gave some wrong answer. Here it says here inside a function, but that's not true. S is outside a function. Yeah. But let's ask anyway. Maybe it gives some ideas. What does the 2 bytes description value? What does the what does the description value mean in? Let's see. Index into the debugging type information table, dwarf or steps. Okay. Yeah. Desk 12, type definition, type info for the stack variable. Lookup type information. How can I query type information with object dump or nm tools? Symbol types. Okay. Object dump clang. NM. Okay. Thyme MachO data. Actually, let's go to MachO analyzer data. Here we already have a bunch of stuff. CMD, CD, and then we do LLVM NM minus MZH. M.txt. Let's call this LLVM minus NM minus M, whatever that generates. Was a private external. Okay. Okay, this is not useful. We don't have dwarf type structures. Okay. Let's try it anyway. I'm desperate. Object dump minus MZH LLVM object dump minus minus dwarf equals info dwarf info ZH. Unknown arguments. Doesn't exist. Let's see if there's anything with dwarf in here. Dwarf here. Frames. Frames. Well. Error arguments. Huh? Dwarf frames is unknown. Did you mean dwarf frames? What's the difference? It looks exactly the same. Huh? Oh, dwarf, not dwart. Okay. Dwarf. Where's it? Oh, there is some info. Huh? EH frame contents. What is that? It's a lot of data, but the question is, what is this? I don't know what that means, but it looks interesting. Format dwarf 32. LSDA address. Augmentation. Data. What is that? Well, let's try. Well, it's a frame. Frames. Info. Okay. Yeah. I don't know. Let's see if there's any dwarf information here. I'm surprised that we got some info out of dwarf. But I don't know what this EH frame is. Dump the specified dwarf debug sections. Source level variables. What is debug vars? Debug vars. Registers or memory? Debug vars. I don't know what that is. Debug vars. Should delete this one. Well, that didn't do anything. Debug vars. Debug vars equals ASCII. Yeah, I don't know what to say. Show all symbols. Show all symbols. Dump all symbols. Description values, type index. There's no type index. I guess the EA frame was the exception handler thingy, right? So this dwarf data relates to it. I don't know if that is useful for anything. What was it again? This one, dwarf frames. Let's ask what does this EH frame describe? Dwarf base exception handling. This data is used for stack unwinding. Okay, then we don't care about this. Dwarf 32. Dwarf version is 1. LSDA, personal routine, return address, code alignment factor 1, aligned with this factor, data alignment factor -4, stack offsets user -4 multiplier, return address column, return address is stored in register 8, usually RIP, personality address. Okay. How to unweight the stack for functions using frame pointer based stack management. Yeah, I don't think that this is relevant for us. No. Good. Then how about we get back to this stuff. Link it at O2. View raw steps information. Can the type info only be contained in dwarf data? Type information isn't limited to dwarf. Steps. Older debugging format. Steps was used in older. Yeah. Some binaries may not have debugging info unless compiled with G. Some binaries may not have debugging info unless compiled with G. Yeah. I do have an old Mac file. Well, I think we have the version right. Hold on. Dwarf dump. No dwarf information present. Huh. Extern. Wasn't there some, I thought we had some file where it was describing the version. Ah, here. Compiler, does it say here? This one. I do have a MachO file compiled with this, and it contains steps. It contains steps, but apparently no dwarf. The symbols do have a description. Symbols do have description values from 6 to somewhere around 10,000. I do not know what to do with these values. Where should I look? Let's see what chat says. Oh, he's thinking. Oh. MachO file contains steps, but no dwarf. The description values 6 to 10,000 likely correspond to type information indexes in the steps debugging section. The type definitions are usually stored in LSIM and TyDef. Ooh. But we don't have these things. Yeah, and TyDef is missing. LSIM is also missing. NM app. Okay. LSIM stores type definitions. I don't have OTool. We can try. Okay, so we can try NM minus AP. What does that do? Oof. That just gives a list of things. Do we have OTool? Doesn't look like it. At least not in Clang. So huge applications, by the way. 50 megabytes for this tool. Holy shit, what is in there? Holy shit. Clang Move. 30 megabytes. What the hell? How is this possible? Why are these files so big? Maybe they should have built with DLLs. Yeah. 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 I don't see a O tool here. O tool. Strings. Strings. We do have a string table somewhere here, right? I actually would be interested if this was indexed to strings, C strings. That would be interesting, yeah. Here, string no? I thought we had strings somewhere. Let's check object dump. Something about strings. Maybe it's read object all. Section. There, yeah. This one doesn't show strings. I would like to see the string table. Maybe it can't be dumped that easily. Maybe that's a problem. I mean, this one here is weird. It's empty. String table. Reads objects. each section. Let's ask, find LSIM symbols. We don't have these desk values from M to N LSIM. Manually cross-check symbols and the types. What does that mean? I am on Windows and use LLVM tools. How can I extract the string table, the MachO string table with LLVM tools? Read objects. Okay, I did try this. Steps. Read objects minus steps ZH. Error. Nice try. Yeah, we tried this and that didn't work. Read objects minus string table only gives empty. But the strings are definitely in there, right? NM minus A. NM minus A. What is that? Minus A. Okay, it prints the outrageous list. Yeah, that's not useful. Let's say the command will command is unable to generate a list of strings. The file, the result is empty. Different section than expected. Does not contain separate string table. Symbol names are stored inlined. What? Look for section name C string. Step str. Sections. Read object. Read object. Sections. Yeah. All right, let's go to the top. Okay, so we do have a text section, pick symbol, C string. That is C string. But I haven't seen the step str section. What? I mean, sure, we can open the file in Notepad, yeah, and then we can search for struct, yeah. I don't know why that would be useful though. Shouldn't we search for some type? Struct is not very useful, is it? Type def enum. Well, okay, we can search, I guess. Struct. Oh. Forward instructions. Wow. Okay, but here are strings, right? Yeah. Yeah, this looks like the string section. Yeah, but I mean, if we go to the top of it, that seems to be the top. Yeah. This seems to be the early strings here. Data. Okay, well, there's no type information. It's just the strings that the game uses. Yeah. Yeah. I don't know what this type information description is. Yeah. Yeah, this is it would be a nice idea if it would just index the string table. Yeah, I don't know. We don't have LSIM. LSIM, what does it mean? LSIM. Here, LSIM. In addition to describing types, the LSIM step type also describes locally scoped automatic variables. Refer again. Body, it allocates 2 automatic variables. Scope locally. No, this is for local variables. Let's look at other pages here first. Well, we should have read this earlier when we started. Oh, they didn't know that this existed. This looks like a nice documentation. What is this here? Huh. What are these types here? Where's this coming from? Hmm. 128. What is that? 128. Length information. FE, what is that value? 245, 54. Or 54, I think. FE, yeah, 254. 128. 128. That's hex 80. 80 LSIM. Local SIM. But we don't have this, right? That's a shame. This looks like really useful here. Yeah, looks like we don't have it. Yeah. That's a shame. This would have really helped if we knew the types, but we don't. Yeah. Let's write, unfortunately, the file contains no NLSIM symbols. Does this mean we cannot extract type information? Data type information. It becomes harder, but not impossible. Okay. TyDef. Simple store type def structs enums. Okay, but we don't have TyDef as well. We don't have TyDef. Or do we? What is TyDef? TyDef. Where is it? Huh? Thai def doesn't exist. Okay. A good start. Yeah, but this we don't have such information. Thai def. Since you do have these, yeah, with description values, those numbers may still reference types elsewhere. Yes, and that would be the hope here. Try listing them. Check, do certain symbols have similar disk values? If so, they may reference structs or type diffs. Oh. What does that mean? Structs or type diffs. Do certain symbols have similar disk? Step str. Do we have this? Step str. I can't remember having seen this. We have a CF string. We don't have step str. Nope. Nope, nope. Debug str, no. Nope. Hey, this is cool commands. Let me try this. Object dump section full contents minus full minus contents minus section equals C string unknown command. What? Minus E is what? Full contents. What is the problem? I don't see the problem here. Section C string ZH. Huh? There's no minus E. Whoa, what is this saying? Maybe full contents is... Maybe full contents is unknown. Unknown argument E. Hä? Oh boy. Section value. Section. Full content, it's here. Ah, minus section. Okay, there we go. Aha. Okay. But it's not very useful because it dumps it in binary format. Yeah. Well, not binary, but it's like some binary representation. Not very useful. Full contents. Full contents section C string. Yeah. I mean, it's good ideas. Yeah. Yeah. But it's weird. Like I would assume. I mean, it would be weird if there were values that reference nothing, right? They just sit there and they don't identify anything. So that would be weird. Yeah. Hmm. 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 I do wonder one idea. If we look at symbols and we put an int index, what the hell? Int index 0, and then we say if index plus plus is 6, then we do int a equals 0, put a breakpoint here. So basically, what maybe the index, maybe it refers to symbol index, but then that would be weird, right? But it doesn't hurt to check, right? Okay, so the symbol is GCC2 compiled. Well, that doesn't look like a type. No. What's the next one? Symbol start. No, it doesn't refer to it. That's no. No. That's too bad. Yeah. We don't have this. I mean, reference to C string section. That works because strings are null terminated, right? So we will always know the length from that. So we certainly can work with that. Yeah. Yeah. But with data types that go into the data section, I don't think we can work with that. No. No. That's too bad. What about let me see. Sections. Well, should we look at the segments? I want to see the sections, please. I know we have dumped it somewhere. Here, section headers. There. I would like to see literal 4. Literal 4. Yeah. So I assume all these It looks like it also contains 1 byte types here. This is a 1 byte type. Um, if we have a this looks strange here because this apparently refers to 1 byte here, but there's another byte here. So to me, this looks like a 2 byte type instead. Right? This one could be a 1 byte. But this one, because it would make no sense that there's a 75 here if it's not referenced by anything, right? So I expect that this here, maybe what we can do is we look at this and we say, if the last 2 bytes here are 0, we treat it as a 2 byte type. Yeah, maybe. Maybe. T width. Yeah. Let's double check here. ZH Mac contains no type. Contains no type information. Correct. Debug data type information. Let's say just data. Yeah, I mean, we can work heuristically. Max line length. Let's take a look at this guy. It must be in Thyme. Max line length. Enum 512. 512. Well, if this was, hold on, take a look here. So this must be 512. Yeah, so it must be. So this is Little Indian, right? So I think this is 1000. Huh? That is 4096. Max line length. Oh boy. There's not so many literals, huh? Logic. Yeah, I don't fully understand this stuff yet. This is static float. Intensity rate of change. I'm surprised that there's just so few things in here. Would have expected more. Okay. So it's not as relevant as I thought. I guess the most links to data segment. Yeah. 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 But I think it's not a bad idea. We can always just say, okay, we check if there is a value at the start, then and 3 zeros, and we treat it as a 1 byte. If it is 2 and here's some value set, then we treat it as 2 byte value, and if it has some values here and these two, or here, these two, then we treat it as 4 byte value. Yeah. And if it's a 3F, then it's very likely here a float. Let me see, float bytes representation. Floating point calculator. It doesn't show anything interesting. Float bits. Yeah, this one here, that's good. So decimal presentation 1.0, 3F, yeah. Let's see, 1.2, 3F. Let's say 2. Okay, then it's 40, yeah. So 1, 3F. 0 is 0, or 0, 1, 3D. 3D, 0, 1, 3A. Yeah. Yeah. Hmm. Yeah, maybe we can build some heuristic that is good enough. I don't know. Let's see. Okay. Yeah. Yeah, it's possible that the description value is of no use. Yeah. Yeah. It's a shame. It's a real shame. Yeah. Literal 4. What about the const section? Const. What is in there? Oof. Jump table. Oh. GUID. GUID. Oof. My gosh. Okay, W bonus, and then there's some garbage here. Some data. Yeah. I mean, for this, we would need to know what the struct is. I don't know if we can work with that. Data is, yeah, same bullshit. Unless we know what the structure looks like, we won't be able to use it. All right. The what we could do here is we could look up if there is another symbol at address plus 4 bytes. And if there is, then we know that the value references no more than 4 bytes. So it must be a 4 byte or a 2 byte or a 1 byte, right? If the alignment is 4, which likely it is, because that seems to be the default alignment here. Yeah. So you could do that, yeah. Maybe that helps. It probably doesn't, because with our static variables, we only have a limited amount of data. And a lot of data here is referenced in functions and constructors and so on. Yeah. It would work for some, I guess. Yeah. Like this one here, for example. This one would work. This one would work. This one would work. Yeah. Yeah. Brainwashed. Yeah. Yeah, I don't know. Okay, I think I will take a break here. What's the time? 2 hours, yeah. Okay, we didn't get really far. We didn't actually accomplish anything. Yeah. Yeah. That's a shame. Well, that's it. Wish you a great day or night. Until next time. Goodbye.